somebody remind me, Miss Hyatt, record, and I will post that on Canvas. So if you are ever absent, it should be posted there. I try to post it right after class is over, so that if you're out, you can go back and watch that, because it's really hard for me to catch you up if I don't do that. I've tried to put these notes in Google Slides, and I don't usually use that, so I'm going to might be a little slow with it. All right, so functions is what we're going to talk about for our first unit. A relation is the relationship between the sets of values of ordered pairs, so x's and y's. A relation could be lots of different types of points that are related in some way. But a function has a specific type. Where'd the rest of this go? Did I do it? Hold on. Also, here, you guys are somewhat lucky that you had me the very first time. Not on mistakes that I make during notes, because I make way too many of those. But, why is it not going back? I'm not used to using this one. Okay. Hold on. Let me type this in, because it should be, oh. Hold on. I think I made this is mine. Oh, I didn't put a line under it for filling in the blank. That's what I did wrong. See, that's my new trick. I learned that this summer. Just make everything white so you remember what you actually meant to put in the blank, but it doesn't show up. That way you can print it like that. All right. Okay. Now we're on track. So let me go back to my presentation. All right. Okay. So for something to be a function, so it's a specific type of graph where x values do not repeat. So what it is, it's a rule where if you put in a number, so if you plug in 5, you will get out an answer. But if you won't get two different answers, you'll get one single answer when you put that number in. It's just a rule. You're already familiar with a lot of these. It's stuff like f of x equals 3x minus 4. So you've seen a lot of this before. One big thing that we're going to look at that's going to come up in this unit and then in several other units is domain and range. You have seen it in Math 1, possibly, a little bit. And depending on who you had in Math 2, you may have seen it some. But domain and range. Domain are your possible x values. Range are your possible y values. And we'll talk about that in detail tomorrow. We're just going over which one's x and which one's y here. Coach Wood didn't have 2 last year, did he? None of you guys have had Coach Wood for 2. Maybe some of you did. How many of you had Coach Wood for 1? Nobody had Coach Wood for Math 1? Anyway, if we asked Coach Wood, he would start singing All My Exes Live in Texas on this one. Because your exes live in Texas, and the capital in Dallas is in Texas, and Dallas starts with D, so domain is your exes. That's how he explains it. So if you haven't had the pleasure of having Coach Wood, there's a preview of what you might be getting soon. He's so funny. If you just have a list of ordered pairs, it's pretty simple to find domain and range. So domain would just be the x value. So your x coordinate is the first one here. And you would not want to list something twice if it shows up twice. So it doesn't for this one. So -4, -3, 0, 1, and 3. That would be your domain for this particular relation. And then the range is just simply the y values. So these y values here are our range. So we would have 0, 1, -2, 2, and 3. Okay? And so when we're talking about just list of numbers, the big thing you're looking for, the big thing you're asking yourself is is it a function? Do x values repeat? Okay, so if you have an x that's listed more than once, then you would not have a function. In this case, we don't have any repeated x values. It's okay to have repeated y values, but x values cannot repeat. So the answer here is no, so this is a function. So if the x values do not repeat, you're looking at a function. Now, sometimes the easiest way to look at this is to look at a graph instead of like looking at the list of numbers. So we go to the next slide. We're going to talk about the vertical line test and horizontal line test. Vertical line test you should have done in Math 1. I'll say a lot of stuff like that from like where it comes from. I know good and well you've probably forgotten some things from Math 1. I know at the end of Math 1 some of you have forgotten some things from Math 1. I say this not that you should be an expert on it, but that maybe it rings a bell. Vertical line test. If you have a vertical line and you pass it through the graph, each point as it passes through the graph, if it touches the graph only once, then the relation is a function. So if you have a vertical line and you pass it through the graph and it doesn't hit twice anywhere, it only hits one time everywhere, then that is a function. The horizontal line test is the same thing, but you're going to use a horizontal line. We did not do that in Math 1 because for a horizontal line test, you are testing for one particular type of function. A relation that can pass both the vertical and the horizontal line test is called, this is going to be our bottom one, a 1-to-1 function. Okay? And we'll look at what that means here in a little bit. So let's try some vertical line tests and horizontal line tests. All right, so if we had a vertical line, which I can't draw with this thinking software, I wish I had something better. Oh wait, maybe I can. Can I move it is the question. I can't move it. Okay, that's useless. So if you take a vertical line, so here's our vertical line, pencil. If you take a vertical line and you pass it across this graph like this, if it hits that line in two places, then it is not a function. So what's happening here, like if I draw my vertical line right here, if I draw my vertical line right here, it's hitting at these two places. The coordinate of this point might be like 2, -2, or -2, 2, and this is -2, -2. You've got the x's are repeating. You got two places that have that same x value. So this would be not a function. All right, so let's check 3. If we take our vertical line and we try to pass it across, is there anywhere that it crosses twice? No. That one's good, right? It passes the vertical line test. So it is definitely a function. But I want us to go one step further than we went in Math 1. I want us to also do the horizontal line test, which is going to be harder because I don't think I'm tall enough to do this. But if I try a horizontal line right here, is it going to hit twice there? Yeah. It's going to hit actually like 3 times, right, in some places. So it passes the vertical line test, so it is a function, but it does not pass the horizontal, so that would mean it's just a regular function. It's not a 1-to-1 function. For it to be 1-to-1, it's going to have to pass both of those. So that one's just a function. All right, let's go on. All right, we are going to get some of these that they're going to give to us that are going to give us just an equation and ask us about whether or not it's a function or not. And so we are going to ask ourselves what would Coach Wood do, and we're just going to type it into Desmos because you can use Desmos on every, or you could use the graphing calculator, but Desmos is easier. So I'm not going to make you get your computers out because that'll take a minute, and we don't have a minute at all right now. So if I pull up Desmos over here, split screen it and pull up Desmos, if you get something like this, we're basically going to do it the last problem. We're just going to type it in Desmos to see what it looks like. So if I do f of x, well, I guess it's a y, equals x squared plus 2, I have this graph right here, and actually, I think I have to do it like this. All right, so if I pass a vertical line through that one, is it going to hit twice anywhere? It is not. So it is a function. Is it a one-to-one function? No, it's not, because if I try a horizontal line, which will be a y equals line, let's see if I can make this work. If I try a horizontal line, why is it not? Oh, it's because of that equal sign right there. Okay, here we go. So I can move it. If I try it, there's lots of places it's going to hit twice. So pretty straightforward. I accidentally put the same one there twice and didn't change it, so let's not worry about example 5. This is one of my errors. On notes, it doesn't really count because on notes I make a lot of mistakes and stuff. But you guys are lucky that we've not done this on a quiz or a test or a homework assignment that I posted the answer key for. If you find something that I have made a mistake on, so if I post the answer key but one of the answers is wrong, or if on a test there's not a correct answer choice or something like that, let me know. If you are correct and I have actually made a mistake, I will give you an extra bathroom pass or late work pass, whichever one you want, because it helps me find the mistakes in the stuff I've done, and since this is the first time I've ever done Math 3 and I'm having to create all this stuff new, there's a lot of opportunity for bathroom passes out there. I've probably made a lot of mistakes. So if you find mistakes, let me know. Like I said, notes don't count though because I just messed stuff up. Also, like spelling errors and grammar errors do not count unless they mess up like the answer you would get on the problem. So like if I just spell even wrong and put 3 E's in it or something, that doesn't count. But if I accidentally put odd instead of even and it messes up the problem, then that counts. All right, let's see. Oh, time. Getting close. All right, let's try this one. 3 to the x power. Okay, this one. Finally, we've got one. Vertical line test. Does this one pass the vertical line test? It's good. What about horizontal? Yeah, I think so. It gets awful flat right here. But what happens with this particular graph, if you zoom in, it is actually still decreasing just a teeny tiny bit. Like it's going down. It's what we call a horizontal asymptote on that graph. So this one would be a one-to-one function. And we're not going to do a lot with this one-to-one function right now, but when we get to inverses at the end of this unit, we're going to talk about what it means to have that. So, let's see. Function notation. All right, we're going to do this slide and then we'll have to quit. We'll finish the rest of these tomorrow. All right, so function notation is really important. Whatever variable is right here is your independent variable. So that means it should be the variable that you see over here in your equation, or whatever that is. This is the dependent. So whatever that equals is going to depend on the number that you plug in. Okay? We're going to use f of x, g of x, h of x, k of x a lot. We'll still use y equals some too, but we'll use function notation a lot. It allows for individual functions not, oh, hold on. It allows for individual function, oh, names. I think that's supposed to be names. Sorry. This is the first time I've done these notes. I don't have them. To avoid confusion as to which function, oh, I need bigger lines, is being examined, it easily identifies the independent variable in a problem. Okay, so we didn't get through all of that, but we